In this lesson, we will be able to recognize the fractional size of a partition when the whole has not been completely partitioned. Today, we will use our previous knowledge about unit fractions and equal partitions to take a deeper look at unit fractions. As a reminder, a unit fraction has 1 as the numerator, the top number, meaning we are only considering one partition of the whole. A partition is a division into portions or shares. In other words, a separation as of 2 or more things. Let's start off by taking a look at this square. I can count 1, 2, 3, 4 areas in which the square has been partitioned. Each of these areas are equal. I also noticed that only one of the areas are shaded. I would label this fraction as 1/4. The denominator, the bottom number, is 4 because there are 4 equal areas. The numerator, the top number, is 1 because there is only one area being considered. Now let's look at the next square. This square is partitioned into 3 areas. This time, not all the areas are equal. If I were to say 1/3 of the square was shaded, I would be incorrect. When I compare the first image with this image, I am able to see that the same portion of the whole is shaded in both pictures. When naming fractions, we need to remember that we look at equal parts. Sometimes we are shown a model or object that doesn't show all the partitions, or partitions may not be equal. For example, when someone cuts a slice of cake without cutting the entire cake into pieces first, the slice on the plate is not 1/2 of the whole cake, just because the cake has been partitioned into only 2 parts. And think about this. If I had a home with only 6 rooms, I could not fairly say each room represented 1/6 of my house. Each of my rooms are a different size, and I know my bathroom is definitely not the same size as my living room. I would need to take a more in-depth look at my home to discover what fraction each room represents. Next, we are going to look at fractions with a math manipulative called pattern blocks. You will see a yellow hexagon, a red trapezoid, a blue rhombus, and a green triangle. For the first problem, I am going to consider my yellow hexagon as the whole. If I place my green triangle on top of my yellow hexagon, I want to find what fraction my green triangle represents. First, I need to see how many green triangles it takes to cover my whole. If I place my triangles on top, I can count how many partitions my whole is being divided into. It took 6 green triangles to cover my whole. The denominator will be 6 because it takes 6 green triangles to cover the yellow hexagon. In this problem, we were only considering 1 green triangle. My numerator will be 1, so our fraction would be 1/6. Our next problem, let's have the red trapezoid be the whole. Using the green triangle, I want to find what fraction the green triangle represents. First, I need to see how many green triangles it will take to cover my whole. It takes 3 copies of the triangle to cover the whole, so this time my fraction will be 1/3. Our next problem is a little different. I'm going to have the yellow hexagon be the whole and place the red trapezoid on top, as well as the green triangle and blue rhombus. This time, my whole is not being partitioned into 3 equal parts. I need to find what fraction each of the parts represents. Let's start off by finding the fraction of the red trapezoid. Let's see how many red trapezoids it would take to cover my whole. 1, 2. The whole has been partitioned into 2 equal parts. So my red trapezoid represents 1/2 of my yellow hexagon. Now let's find the fraction of the green triangle. We can place our green triangles on top. As you may remember before, we were able to fit exactly 6 triangles to cover our whole. I'm only considering 1 green triangle, so I know this green triangle represents 1/6 of my whole. Now let's try and see if we can find the fraction of this blue rhombus. First, I need to see how many of the blue rhombus it would take to cover my whole into equal partitions. 1, 2, 3 blue rhombuses cover my whole. We are only considering one blue rhombus, so the blue rhombus represents 1/3 of my whole. Today, our objective was to recognize the fractional size of a partition when the whole has not been completely partitioned. As we looked at pictures, used life examples, and modeled with pattern blocks, we were able to name unit fractions when the whole was not completely partitioned already.